everybody, welcome back to another video. This is the second video I'm making to help my current Math 117 students prepare for the Module C exam. If you haven't seen the first review quiz video, go watch that because a lot of these problems are going to be the same. So maybe I'll go a little bit more quickly on those. But there are a few new problems in here, new styles of problems. I think that's all I want to say. So let's get started. So this is a problem that we saw previously. And like I said, the way to do it by hand is you can expand the right-hand side and then kind of collect like terms and solve. But we can also just do this in Desmos. So because I solved a very similar problem in the previous video, why don't we do this one in Desmos? So I'm going to have, let's see, in Desmos, I'll type this as 2x squared. So let me go to Desmos. Oops. Let's do 2x squared minus, and then what was that? 13x plus 19. So that's one parabola. Then on the other side, we're going to have x minus 3 squared. And now we just need the two intersection points. So that happens when x equals 2 and x equals 5. So we'll write our answer as u equals 2, 5. So notice here, I needed to use x instead of u just because Desmos would be upset if I used u instead, but 2 and 5 are the answers. All right, very good. Let's keep going. Oops, I'm trying to use keyboard shortcuts to change between the tabs and they're getting a little stuck. All right, this one's saying a ball is thrown from a height of 47 meters with an initial downward velocity of 4 meters per second. The ball's height in meters after t seconds is given by the following. So notice this is a quadratic equation where the coefficient on the t squared term is -5. So this means we have a downward pointing parabola. And give me 1 second. My annotations are being weird, so I'm just going to plug my tablet in again. All right, I think this fixed things. Let's see. Yeah, this is better. All right, so our parabola is looking down like this. And this is good because, if the parabola was pointing up, well, we throw the ball, up and then it goes up forever. It'll never hit the ground. So this is telling me the height of the ball in terms of t seconds. So it's saying how long after the ball is thrown does it hit the ground? Well, what's the height when it hits the ground? Height is 0 when the ball hits the ground. Now, I know this style of problem, so let's see. I'm going to plug this into Desmos, and basically we're saying where is this equation equal to 0? When is h equal to 0? Typically for these, you get a positive and a negative answer, and because t is time, we pick the positive one. But maybe we'll get, it's kind of weird that they're telling us that we can use or, but like it should only hit the ground once, is my point. And it should happen at a positive time. But let's go to Desmos. So we have 47. Here, let's go here. Oops, minus x, or 4x minus 5x squared. All right, so you can see, yeah, one of the values, t, is negative, so we don't want that. And the other one, let's see, did I write this incorrectly? I can put this here. And let's see, what is this as a fraction? Maybe it's something nice. Nope. Did I type this incorrectly? 47 minus 4x minus 5x squared. Do they want us to round it all? Oh, yes, round your answers to the nearest hundredth. Okay, very good. So to the nearest hundredth, 10 hundredths, so it'll be 2.69 seconds. All right, very good. Let's keep going. All right, this one's saying, we saw an example of this, previously, but below we have the graph of negative x cubed. We're going to translate it to make the graph of y equals negative quantity x minus 2 cubed minus 4. So we already took care of the negative out front. So here, because it's x minus 2, so this minus 2 is attached to the x, we're going to do the opposite of what you'd think. So this is going to be a shift to the right by 2. Shift right by 2. And -4 means shift down by 4. All right, so let's do it. Translation, and I'm going to move this to, okay, so shift right by 2, 1, 2, shift down by 4, 1, 2, 3, 4. Very good. Again, if we wanted to check our answer, all we have to do is come to Desmos and say, well, what does the graph, oops, wait, minus out front, minus x minus 2 cubed minus 4, and we can see here, well, maybe not that point, but this is going to be 2, oops, -4. So let's check. 2, -4. So this looks good. All right, we'll keep going. All right, this one's saying for each graph, choose the function that best describes it. So these, worst case, just plug these in Desmos and see what you get. This one is going to be x cubed. This is 1 over x. This is absolute value of x, and this is y equals x. These are things you could memorize them. You'll kind of learn with experience, but otherwise, you can just plot the options in Desmos and kind of match them as best as you can. Very good. All right, we have a graph of a function h. Use the graph to find the following. If there is more than one answer, separate them with commas. All right, local minimum. So what this means is local minimum is, in theory, I can draw a little kind of neighborhood around the minimum, and it's smaller than everything nearby. So for instance, here x equals -2 is a local minimum because if I draw like a little interval around it, notice it's smaller than everything to the left and right. So I can find this little interval. Same thing with x equals 2. Now, here, these wouldn't be minimums and other points wouldn't because I can go a little bit to the left and right and find smaller values. So local minimum values of h. Oh, and I guess here, so here it wants the values, all values at which h has a local minimum. So this will be at x equals -2, x equals 2. And the value here is -1. So we'll put -1 here. Very good. Let me clear drawings. All right. Here we have two functions, so we need to do f plus g and f times g, and then we want to give their domains using interval notation. All right, so f plus g, I'm just going to add them together. So f of x is 2x minus 3 under the square root, so 2x minus 3. And then we need to do plus g, so plus x squared minus 2. Very good. What's the domain of this? Well, what goes wrong here is we don't want to have anything negative under the square root. So we need 2x minus 3 to be greater than or equal to 0, which means that 2x is greater than or equal to 3. So x is greater than or equal to 3 over 2. So if I were to draw this on a number line, here's 3 over 2. So I do closed circle because it's included, and I want x larger than 3 over 2. So I'm going to shade everything to the right. In interval notation, this is a closed bracket. 3 over 2 going up to infinity, which we do with an open bracket because infinity is not a number. I'm never going to reach infinity. So let's do here, and I'm going to do 3 over 2, comma, infinity. Very good. Now for f times g, I'm just going to take the product of them. So I'm going to have square root of 2x minus 3 and times x squared minus 2. This is actually going to have the same domain. Again, the only thing that can go wrong is well, what happens if the square root, what's under the square root is less than or equal to 0. So exactly the same thing here. So let's do 3 over 2 to infinity. Perfect. Let's keep going. All right. Now we have composition. So we want to do f of g of x. So this is f evaluated at g of x. So everywhere I see x in f of x, I'm going to plug in 7 over x. So this will be 4 over 7 over x minus 3. Very good. All right, so 4 over 7 over x minus 3. All right, these domain ones get a little bit trickier. So a couple of things can go wrong. First, So I'm doing f of g of x. X can't be 0 because if I do f of g of 0, well, g of 0 is not defined, right? Because it has a 0 in the denominator. So if I'm looking at my number line, let's put 0 here. I need to throw away 0. So I'm going to mark an X everywhere I need to throw away values. So X can't be 0. Another thing is, well, for f of x, now I have f of g of x. If g of x is equal to 3, well then 3 minus 3 in the denominator is 0, so that's bad. So where does g of x, so I can't have this equal to 3. Where is g of x equal to 3? Well, 7 over x is equal to 3 if and only if 7 is equal to 3x, which means that x is equal to 7 over 3. So we can't have x equal to 7 over 3. I need to throw this out. And then the very last thing is, we'll notice in the composition here, well, if this is equal to 0, we're going to get basically the same thing. So notice if this is equal to 0, then 7 over x is equal to 3, which means that 7 is equal to 3x. So x is equal to 7 over 3. So we need to throw away these 2 points. So this splits up our number line into 3 pieces. We have negative infinity up to 0. And I do an open parenthesis on 0 because I can't include it, union. Then I go from 0 to 7 over 3, and open parenthesis on both because I can't include either of them. And then union 7 over 3 to infinity. All right, let's type in the answer. So we're going to have negative infinity up to 0. Again, open, union, 0 to 7 over 3. And then union 7 over 3 to infinity. Just checking our answers. All right, this looks good. Let's keep going. All right, this one's saying, all right, we have this function g of x. It's a parabola and it's upside down because the leading coefficient is negative. So think about it, is this going to have a maximum or a minimum? Well, it's going to have a maximum. And, let's just go plug this in to Desmos. So we have, let's see, negative 3x squared plus 6x plus 1. All right, so here's the maximum. It happens at 1, 4. So max at 1, 4. So what is the function's minimum or maximum value? Well, that's 4. Where does it happen? Well, when x is equal to 1. Very good. All right, this one's saying plot the parabola y equals 2x squared minus 8x plus 6. Plot 5 points on the parabola, the vertex, 2 points to the left of the vertex, and 2 points to the right of the vertex. You could put this in vertex form, which we had some practice with in the previous video. And the way you would do that is by completing the square. But since we have Desmos, let's just use Desmos. And I'm going to take a sip of coffee and then we'll go from there. All right, we have 2x squared minus 8x plus 6. All right, 2x squared minus 8x plus 6. All right, vertex is at 2, negative 2. All right, so let's plot 2, negative 2. Good. And then let's do 2 points to the left. So we have 1, 0, and 3, 0. Oops, that's 2, 3, 0. Very good. And then we need 2 more points. So let's get those. What looks easy? Yeah, 0, 6, and 4, 6. All right, very good. This looks good. All right, let's keep going. All right, this one's saying Teresa has 440 meters of fencing and wishes to form 3 sides of a rectangular field. The fourth side borders a river and will not need fencing. As shown below, one of the sides has length x in meters. Find a function that gives the area, a of x, of the field in square meters in terms of x. All right, so for this one, we know we have x here and the same length x here. So here's x. And then let's call this long side y. So we know, okay, there's 440 meters of fencing. So x plus y, so 2x plus y is equal to 440. And all right, we want the area, so that would be x times y. So we know that y equals 440 minus 2x. So x times y is the area. So x times 440 minus 2x. And why don't we expand it? So we have 440x minus 2x squared. All right. So 440x minus 2x squared. Very good. And it's saying what side length x gives the maximum area that the field can have? Well, a of x is a parabola, so we'll plot it and we'll see where the maximum is. So 440x minus 2x squared. And we're going to need to zoom out a bit. All right, so this happens when x is 110 meters. Very good. And it's saying, well, what is the maximum area the field can have? Well, this is the maximum value for the area function, so it's 24,200. All right, very good. Let's keep going. All right, this one's saying graph all vertical and horizontal asymptotes of the rational function. So this is another one where I kind of did a lot of explanation in the first video, so go check it out. Otherwise, let's take a look here. Now we have two linear terms. One thing that's, something to keep in mind is you don't want to be able to cancel out the linear terms. Or like if you do, you're going to get a hole in the graph and you're not going to get an asymptote. But I can't divide 2x minus 9 is negative 6x minus 7 evenly. So there's going to be a vertical asymptote where the denominator is equal to 0. So that's when 2x is equal to 9. In other words, x is equal to 9 over 2. So let's do our vertical asymptote. So if x is equal to 9 over 2, and let's just say y equals 0. There's our asymptote. Very good. Now, horizontal asymptotes, remember, there's three things that can happen. Either the degree of the numerator is larger than the degree of the denominator, they're the same, or the degree of the denominator is larger. In this case, the degree of the numerator is the same as the degree of the denominator. So we have negative 6x over 2x. So the horizontal asymptote is the ratio of the leading terms. So the highest degree terms. Here it's x. So horizontal asymptote is given by negative 6 over 2. When that's negative 3. So let's do negative 3. All right, very good. And that should do it. Okay. This one's saying Shun is walking. D of t given below is his distance in kilometer from Townsville after t hours of walking. So the function d takes t hours and gives me distance. So the inverse function, it takes distance and tells me something about hours. So which statement best describes d inverse of x? Well, it's not a reciprocal, and it's not a ratio. And okay, this answer is saying the amount of time he has walked in hours when he is x kilometer from Tomsville. That looks good. And notice if it's his distance from Tomsville in kilometers after he has walked x hours, well, that's what d of t is, but with the variables flipped. So it's going to be this one. Very good. Now they want us to compute the inverse. Well, remember, inverse is I swap x and y and solve. So our original function, I'm going to use y for d of t, and then put this as 10.4 minus 4x. And then I'm going to say, well, x equals 10.4 minus 4y and solve for y. So then negative 4y equals x minus 10.4. Y equals x minus 10.4 over negative 4. So let's type that in for our inverse. X minus 10.4 divided by negative 4. And now we want the inverse of 5.2. So this is a good question for Desmos. So I'm going to come over here and I'm going to say f of x equals 10.4 minus 4x. And we're going to need to zoom. Let me go to the origin. All right, here is our function. For the inverse, I will say x equals f of y. So that's our inverse function. Notice we also said, well, it's x minus 10.4. I'll call this g of x equals 10.4 over negative 4. So notice the two lines coincide. So that means we got the inverse correct. And then we wanted what? 5.2. So I'll do g of 5.2. So 1.3. All right, very good. Let's submit. And we got 100%. So very good. As a reminder, you can click the report and this will show you all of the questions that you got right and wrong. Let me know if you have any questions and good luck studying. Bye, everyone.